Hello everyone. In section 2.7, we are going to discuss solving linear inequalities. Any inequality in the form x plus b less than c is called a linear inequality in one variable x. The inequality symbol may be less than, greater than. With underscore, we say that is less than or equal to, and greater than or equal to. There are infinitely many solutions to the inequality x less than 3, namely all real numbers that are less than 3. Although we cannot list all the solutions, we can make a drawing on the real number line that represents these solutions. Such a drawing is called the graph of the inequality. Graphs of solutions to linear inequalities are shown on a real number line by shading all points representing numbers that are solutions. Square brackets indicate endpoints that are solutions, parentheses indicate endpoints that are not solutions. So to draw the graph of the inequality x less than 3, we can first draw a real number line, and then put 3 in the middle, somewhere on the real number line. And then we're going to shade the part to the left of 3 on the real number line to represent all the numbers that are solutions, because we understand the smaller numbers on the real number line are on the left, and the inequality is x less than 3. At last, we're going to use parentheses to indicate that 3, the endpoint, is not a solution. The table below shows 4 inequalities. Their solution sets using interval and set builder notations and graphs of the solution sets. The first case is x greater than a. So we're going to put a on the real number line and shade the part to the right of a to represent all the numbers that are solutions. And also we use parentheses at a because a is not a solution in this case. And the set builder notation are very similar to inequality. We just use extra pair of parentheses to particularly indicate this is a set. Also, we use x to represent all the numbers in this set. So the set builder notation, all you need to do is just add the extra pair of braces and also use an x. So you will say, you can read this as the set for all x such that x is greater than a. The interval notation always uses a pair of 2 numbers, and the number on the left represents the smallest possible number in this set. On the graph, it is the left endpoint. The number on the right actually is the right endpoint, which also means the biggest possible value in this set. And in this case, x greater than a, we don't have a particular number as the right endpoint for the graph because the graph actually extends to the right infinitely, but we can think of this infinity as the right endpoint. So the pair of 2 numbers will be a, comma, infinity. And also we use parentheses because a is not in the solution and infinity is not a particular number. The second case, x greater than a, greater than or equal to a. So in this case, we're going to use square bracket instead of parentheses because actually a is in the solution set. The third case, x less than b. So we're going to shade the part to the left of b on the real number line to represent the set of all numbers that are solutions. And there is no particular left endpoint, but since the graph extends to the left infinitely, but we can think of negative infinity as the left endpoint. So the pair of two numbers will be negative infinity, comma, b. We also use parentheses because b is not in the solution set. So the last case, x less than or equal to b, the interval notation will be negative infinity, comma, b, square bracket. Again, beside the negative infinity, we always use parentheses, but beside b, we gotta use square bracket because this time b is a solution in the set. B is included in the solution set. Let's see some examples. Graph the solution of each inequality on a number line and then express the solutions in set builder notation and interval notation. The first example, x greater than negative 4. Let's first find out negative 4 on the real number line. And then because we're doing x greater than negative 4, so you're going to shade the part that is to the right of negative 4. And then we're going to decide to use parentheses because negative 4 is not included in the solution set. The inequality is x strictly greater than negative 4. So the set builder notation will be brace x for all x such that x is greater than negative 4. Close it. And the interval notation, you're going to start from left endpoint, negative 4, parentheses, negative 4, comma, all the way to infinity. Again, the interval notation, you always use pair of two numbers from smaller number to the bigger number, okay? From left to right. So next example, negative 2 less than or equal to x less than 7. To graph this, first you need to find out negative 2 and 7 on the graph. And because the left part of this inequality is negative 2 less than or equal to x, and the negative 2 less than or equal to x is the same as x greater than or equal to negative 2. They are equivalent. So you are graphing the inequality x greater than or equal to negative 2. So you're going to shade the part that is to the right of negative 2. And then we'll also decide to use square bracket because you have underscore. It means inclusive. Negative 2, the endpoint negative 2 is in the solution set. And the second part of this inequality is x less than 7. Okay. For the x less than 7, you gotta graph the part that is to the left of 7. And also use parentheses at x equal to 7 because 7 is not in the solution set. And you can see, the double shaded area is for the graph of this inequality because you have two parts of this inequality. Also, we call it compound inequality. Both two inequalities have to be satisfied at the same time. So double shaded area on the real number line represents the graph for this inequality. And the interval notation for this double shaded area from left to right, the left endpoint is negative 2. Use square bracket, comma, 7, parentheses. More examples. You express the solution set of the inequality in interval notation and graph the interval. So you found 0 on the real number line, x greater than or equal to 0 for this example. And then you shade the part to the right of 0. Also use square bracket and x equal to 0 because it's x greater than or equal to 0. 0 is a solution in the solution set. And the interval notation will be from 0, comma, all the way to infinity. And you use square bracket beside 0, parentheses beside infinity. The last example, x less than 5, that's a function out of 5 on the real number line, and the shade part to the left of 5. Also, we use parentheses. So the interval notation will be left endpoint, negative infinity, parentheses, comma, the right endpoint 5, parentheses. Now we're going to learn properties we're going to use to solve linear inequalities. Similar to solving equations, we have two properties to use. One is addition property, another one is multiplication property. The addition property says if the same quantity is added to or subtracted from both sides of an inequality, the resulting inequality is equivalent to the original one. Mathematically, you can say if a less than b, then a plus c less than b plus c. If a less than b, then a minus c less than b minus c. A simple example, x plus 3 less than 5. So to leave x by itself, you can subtract 3 on both sides of this inequality. That way you will have x by itself on the left hand side, and right hand side is 5 minus 3, which is 2. So x less than 2 is the solution set for this inequality. So this one is very, very similar as the, I will say it's identical to the addition property of solving equation. The only difference is for solving inequality, oftentimes you will end up with a solution set rather than a unique number as solution of equation. So for the multiplication property, however, you gotta be careful. If you multiply a positive number on both sides of inequality, you will still have equivalent inequality. But if you multiply a negative number on both sides, you have to reverse the symbol in order to get equivalent inequality. The reason of that is quite simple. Let me give you a simple, illustration of this property. For example, if you have 6 greater than 3, okay, and you can, which is a true statement, you can multiply a positive number on both sides. You end up with 12 on the left hand side and 6 on the right hand side. And 12 is still bigger than 6, which you got a true statement still, without reversing the inequality symbol. But if you divide or multiply by a negative number on both sides, say negative 2, this time you have negative 12 on the left hand side. The right hand side is negative 6, and you know negative 12 is less than negative 6. So you gotta switch symbol in order to get true statement when you multiply a negative number on both sides. Two simple examples. Solve 5x greater than or equal to 28. In order to leave x by itself, you need to divide by 5 on both sides by the positive multiplication property. And you don't have to reverse the symbol to solve this inequality. So the final answer is x greater than or equal to 28 over 5. Which means the set of all real numbers such that x is greater than or equal to 28 over 5 as the solution set of this inequality. So the example for negative multiplication property, negative 5x greater or equal to 28. So you're going to divide by negative 5 this time on both sides of this inequality. But when you divide negative number on both sides of this inequality, so instead of greater or equal to, you'll end up with less than or equal to. So this is the solution set for this inequality. Notice also I move that negative sign from the denominator to the front. This is still equivalent to original number 28 over negative 5. Now we're ready to apply those two properties and also using different notations to solve linear inequalities using the following steps. Step 1. Simplify the algebraic expression on each side. Step 2. Use the addition property of inequality to collect all the variable terms on one side and all the constant terms on the other side. Step 3. Use the multiplication property of inequality to isolate the variable and solve. Then reverse the symbol of the inequality when multiplying or dividing both sides by a negative number. Step 4. Express the solution set in a set builder notation, interval notation, or graph the solution set on a real number line. Let's see a whole bunch of examples. The first one is quite straightforward. X plus 6 less than 9. Your goal is to leave x by itself. You don't have anything to simplify for the step 1, so you can go ahead, do the step 2, use the addition property of inequality to collect all terms, variable terms on one side and all the constant terms on the other side. So in this case, you will want to leave x, the variable term x term, on the left hand side and numbers to the other side. So we're going to do the opposite of plus 6, which is minus 6 on both sides. So end up with x by itself, and the right hand side is 3. So x less than 3 is the inequality, is the solution set for this example. And also you can use interval notation to represent the solution set. In this case, you will use negative infinity as the left endpoint for the solution set, and 3 to be the right endpoint. And also you have to use parentheses for both. So this problem you also don't need, the step 3, which is the multiplication property, because after applying the addition property, you already have x by itself. The next example, negative 6x less than 18. So you're going to apply the multiplication property directly to leave x by itself by dividing negative 6 on both sides. But be careful, if you divide or multiply by a negative number on both sides, you got to reverse the inequality symbol. And negative 18 over 6 is negative 3. And the interval notation will be negative 3 as left endpoint, parentheses, infinity as right endpoint. Let's see this example. 2x plus 3 less than or equal to 4x plus 12. So step 1, let's simplify by distributing that 2. 2 times x is 2x. 2 times positive 3 is plus 6. Less than or equal to 4x plus 12. So that's step 1. Step 2, you can move all the variable terms to one side and the numbers to the other side. So in this case, let's try to move the variable terms to the left-hand side. So you're going to do the opposite of plus 4x on the right-hand side and the left-hand side. And since you decide to move variable terms to the left-hand side, which means the numbers have to go to the right-hand side. So you're going to do the opposite of plus 6, which is minus 6 on both sides. And you end up with 4x minus 2x, negative 2x on the left-hand side, and the right-hand side is 6. So this is the work of second step. Third step, you're going to apply the multiplication property to leave x by itself. So in this case, you're going to divide by the coefficient of negative 2 on both sides. But if you do that, remember to reverse the symbol, okay? So it will be x greater than or equal to 6 over negative 2 is negative 3. Step 4, you can represent that inequality with an interval notation. So because it's x greater than or equal to negative 3 will be the left endpoint. You're going to use square bracket because negative 3 actually is a solution, comma, infinity as the right endpoint. So that's your final answer. This example is an inequality involving fractions. So the strategy we use is very similar as solving equations, linear equations involving fractions. So we always try to find out the LCD as the very first step to simplify. So here for this inequality, we have denominator 10 and 5 and 5. LCD for those denominators will be equal to 10, which is the least common denominator. Also, you can say that's the lowest common multiple for all those denominators. Once you have found out the LCD, you're going to multiply that LCD on both sides. By that LCD, equivalently, you have to multiply all 4 terms in original inequality by that LCD 10. Let me move this real number line downward a little bit further. And then you do the cancellation to get rid of all those denominators, okay? So 10 over 10 is 1, and 1 times 3x is 3x. 10 times 1 is 10. And 1/5 times 10 is 2, minus, you cancel 5, both top and bottom. 2 left for the numerator, so you have 2x for the last term. And then let's try to move all the variable terms to the left-hand side by adding 2x on both sides, and numbers to the other side by subtracting 10 from both sides. So you end up with 5x greater than or equal to negative 8. Now I'm going to divide by 5 on both sides because 5 is a positive number. So based on the positive multiplication property, you will not switch the symbol. So x greater than or equal to negative 8 over 5 is your solution set. To graph it, you can put negative 8 over 5 on the real number line first. But notice that negative 8 over 5 is equal to negative 1.6. So it is a number in between negative 1 and negative 2. So you can use a point in between negative 2 and negative 1 to represent negative 8 over 5. And also it's greater than or equal to, so you gotta use a square bracket to be at x equal to negative 8 over 5. And also you shade that part to the right of that number. So this is the graph of the inequality x greater than or equal to negative 8 over 5. And the interval notation will be negative 8 over 5, comma, infinity. And the square bracket beside negative 8 over 5, infinity, you use parentheses. That will be the interval notation for the solution set for this question. So last question in this section is actually an application problem. A student made a 74 and an 84 on the first two tests. What grade must the student make on the third test to have an average of at least 80? Which means that student is shooting for an B. Some students can figure out this without using application of solving inequality. But if you try to apply the strategy we learned previously to solve an equation, you can solve this problem easily as well. So first, let's understand what we are given, what we are trying to figure out. Okay, so we are given the score for the first two tests. We're asked to figure out what's the score for the third test, so that if you do the average of those three tests, it will be 80 or higher. Okay, so first let's assign a variable. Step 1. Let x be the score of the third test. Be the score of the third test. Okay. And the second step, you can actually represent other quantities in terms of x, if necessary. In this case, because we're dealing with average, so with the third test to be assumed as a variable x, we can actually figure out what will be the average of those three tests, which is equal to the total of those three tests divided by the number of tests, which is 3. So this is actually the average of 3 tests. It's an expression in terms of x. And the third step, you can actually write out the inequality using certain rules of common sense. And in this case, the rule or the condition is the average will be 80 or higher. So our inequality will be 74 plus 84 over x, or plus x, over 3 greater than or equal to 80. So at least in this case translates to the mathematical symbol greater than or equal to. To solve this inequality for x, you can first get rid of that denominator 3 by multiplying 3 on both sides. That way, 3/3 cancel out. Also, the numerator 74 plus 84, you can simplify a little bit to be 158 plus x greater than or equal to 240. This inequality actually really makes sense because, in order to get an average, 80 or higher, you understand your total has to be 240 or higher. So some students can write out the inequality directly without using average idea. They just use, the total points in order to get the average 80. And then for this simpler inequality, to leave x by itself, you can just subtract 158 on both sides. And we end up with x is greater than or equal to 82 as the final solution. And the last step, you can reason our solution in original wording. So you can see in order to get an average of at least 80, the third test has to be 82. At least 82. And you can actually verify it. If third test is 82, 82 plus 74 plus 84 is 240. Total points divided by 3 is actually 80. Right? Okay, this example concludes our entire section. In this section, we actually learn how to represent the solution set, the two properties we can use to solve inequality, and then we practiced a whole bunch of examples, and in the end we have an application problem of solving inequality. This concludes this entire section. Alright, I hope you found out this video helpful. Remember, the homework 2.7 assignment in my labs class is due on this Monday. It's a new deadline. And our test is due on this Wednesday. So it's really around the corner. And on Tuesday, we're going to have a review section. If you have any questions, please don't hesitate to contact me. Alright, thanks for watching.